Hello. In this video, we want to answer this question from my past exam paper. So, the complex number u is given by u is equals to minus 1 minus I root 3. Express u in the form r cos theta plus I sin theta, where our r is greater than 0 and our theta is between minus pi and pi. We're going to give our r and theta values in exact form. So this form is what we call the polar form. The r, it represents the modulus of the complex number that we're given, right? So r is the modulus of our u, and the theta is the argument of u. So we're going to say the modulus of u is equals to the square root of minus 1 squared plus minus root 3 squared. Simplifying this, we get the square root of 4, and the square root of 4 is 2. We are not going to consider the square root of 4 to be minus 2 because already we are told that our r has to be greater than 0. And then we also need to find the argument of u, which is our theta, right? So our theta is equals to arctan of minus root 3 over minus 1. So if we do this, our theta is going to be negative pi over 3. Okay, let's look at it on a diagram. We have minus 1 here, and then we have minus root 3 here. So you will see that our complex number, right, is in the third quadrant, right? So our angle, we are saying our theta is this one, which is a pi over 3, right? So now we were told that when we are looking for the argument, we start from the positive real axis going anti-clockwise. But you will see that if we are to consider that angle, we have to consider this angle. And this whole angle is outside of the range because we are given a range of minus pi to pi, right? So this whole angle, it's now it's now outside of the range that we have. So we're going to consider now this angle from here to here. So if this is pi over 3, it means this one, it's now 2 pi over 3, but it has to be in negative. So our theta is in negative 2 pi over 3. Okay, I hope we understand that part. Right, so now when we are now writing it in this form, we are saying that u is equals to our r, we said it's 2, then cos our theta is in negative 2 pi over 3 plus I sine negative 2 pi over 3, and we are done. So we have managed to write our u in polar form. Okay, so now we move on to part B, right? And then for our part B, we are given a complex number v, which is equals to 5 cos 1 over 6 pi plus I sine 1 over 6 pi. Express the complex number uv in this form. This is the exponential form. So we need our r. Our r is still the modulus, right? And our theta is the argument. But now this r is the modulus of u over v, right? And the theta is the argument of u over v. So first we need to find what is the modulus of u over v, right? So if we have two complex numbers in general, if we have two complex numbers z1 and z2, when we have z1 divided by z2, the modulus of z1 divided by z2 is the same as the modulus of z1 divided by the modulus of z2. So this is a result that we want to make use of, all right? And also, another result that we want to make use of is the argument of z1 divided by z2 is equals to the argument of z1 minus the argument of z2. So these are the results that we want to make use of, right? So we want the modulus of v over u, that is our r, right? So the modulus of v over u is equals to the modulus of v divided by the modulus of u. And this gives us the modulus of v is here. This is the r, right? So this is 5 over, for u from the first part we got that it's a 2. So the modulus of v over u is 5 over 2, right? And then now we want the argument, right? So we want the argument of v over u, which is the argument of v minus the argument of u. But what is the argument of v? The argument of v is this part, the 1 over 6 pi. So we're going to have 1 over 6 pi. And the argument of u, from our previous calculation, we saw that it's minus 2 pi over 3, right? So adding this will give us 5 pi over 6. So the argument of v divided by u is 5 pi over 6. So now we want to write this complex number. So we are saying u over v is equals to r is the modulus, right? So it's 5 over 2. And then we have the exponential I, our theta, it's 5 pi over 6. Okay. And so we are done. Okay. I hope you understand.